Now that we have a little bit more of an idea of what a function is, let's look at the graph of a function. So the graph of a function is the set of all points x comma y such that y is equal to f of x. So essentially, our first coordinate will be the numbers we stick into the function, our inputs, and the y coordinates will be the outputs, what we get out of the function. So let's look at a few examples. I have the function f of x equal to x squared. So the simplest way to do this is the point plotting method. We'll pick some numbers for x and stick them in. So -2, -1, 0, 1, and 2. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So now I should be able to plot that. I have the point -2, 4, the point -1, 1, the point 0, 0, the point 1, 1, and the point 2, 4. And then we can connect the dots to get the graph of the function. Let's look at another one, like the square root of x. Once again, I'm going to make my table. I notice that I'm using a square root, so I can't pick any negative numbers for x. So I'm going to do 1, 0, 1. I'm actually not going to do 2. I'm going to skip up to 4 and 9. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So I purposely picked these numbers because I knew they were going to give me a nice output. So I can now plot them. I have the point 0, 0, the point 1, 1, the point 4, 2, and the point 9, 3. And then I can connect the dots. Next, I have f of x equal to x cubed. So once again, I'll make my table. -2, -1, 0, 1, and 2. -2 cubed is -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. And 2 cubed is 8. And now I can plot these. So I have the point -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. And then I can look at connecting the dots. Next, let's look at a piecewise function. So I have this function that's defined by x squared if x is less than or equal to 2, and -2x plus 5 if x is bigger than 2. So I have my f and f of x. I'm going to pick some numbers like -1, 0, 1, 2, 3, and 4. So if I stick in -1, that's less than 2, so I'm in the first case, and -1 squared is 1. 0, I'm still in the first case, 0 squared is 0. With 1, I'm still in the first case, and 1 squared is 1. 2, I'm still in the first case because 2 is less than or equal to 2, so 2 squared is 4. If x is 3, 3 is bigger than 2, so I'm in my second case. And I have -2 times 3 plus 5, which is -1. 4 is bigger than 2, so once again I'm in my second case. -2 times 4 plus 5, that gives me -3. So now I can graph. So I have the point -1, 1, the point 0, 0, the point 1, 1, and the point 2, 4. So I'm going to go ahead and connect those and get the first part of my graph. The next piece, if x is 3, y is -1. If x is 4, y is -3. And I can start to connect these. However, at the point x equal to 2, I can get as close as I need to that, but I'm not actually there. So I'll put an open dot where this line passes through that point. And this is my piecewise function. Next, I want to look at the graph of the absolute value of x. And the absolute value of x is technically a piecewise function. If x is a positive number, greater than or equal to 0, then the absolute value is just that number. And if you're less than 0, so if you're a negative function, a negative number, the absolute value means we want to change the sign, so minus x to change the sign. I can make a table and come up with some numbers to stick in, like -2, -1, 0, 1, 2. -2 is less than 0, so I'm in my second case. It would be -2 or +2. -1 is less than 0, so -1 is 1. The rest of these numbers, I'm going to be in the first case where I'm greater than or equal to 0, and this function is just exactly what my input was, just x. So now, whenever I graph this, I can graph it in pieces. I have the point -2, 2, the point -1, 1, the point 0, 0, 1, 1, and 2, 2. Everything on the right is one piece, and everything on the left is the second piece. I can't actually touch 0 coming from the left, but I can get as close as I need to, and it actually ends up looking like this V. Now I'm going to look at this function, which is a commonly used function known as the greatest integer function. The actual way this function is defined is it is the largest integer less than or equal to the input. So as a couple of examples, f of 4 would be 4, and f of -2 would be -2. So if I input an integer, I just get that integer back. If I look at 1.3, I would get the number 1. If I look at 2.9, I would get the number 2. So it looks at this integer less than that, but also the largest one. So for positive numbers, it's just dropping the negative signs. However, if I look at -3.4, I would actually need to drop down to -4. So what happens when I try to graph this? Well, it's going to be a piecewise function because it is really defined in pieces. And let's start with 0. We know if we put in 0, we get 0 since it's an integer. And all the 0.1s and 0.2s and 0.75, all of them are still going to be 0 because there's no integer less than that, but not 1. When I input 1, I get 1 back out. When I input 1.1 or 1.3 or 1.87, I still get 1, all the way up to as close as I can get to 2, at which point I get 2 back out. 2.7 and 2.91 will all give me 2 until I get to 3. And you can see the pattern and figure out what's going to happen for the negative side of this graph as well. So this is commonly referred to as the step function because you'll notice that it looks like a staircase, like we are climbing steps.